Now we have few examples of factorization of sum or differences of cubes. So we will be using these two identities in these examples, sum of cubes and difference of cubes. The first example, 8x cube plus 125. So you compare this with x cube plus y cube. So what is the term which has a cube equals to 8x cube? X cube is the cube of x and 8 is a cube of 2, perfect cube of 2. So it means 2x whole cube equals to 8x cube. So our A would be 2x. Similarly, 125 is a cube of 5. So 125 can be written as 5 cube. So our B is 5. You may use this A or B, or you may not use this. You can straight away say that 8x cube can be written as 2x whole cube plus 5 whole cube. And then the advantage of using A and B is that if you look at the formulas of x cube plus y cube, the sum of the cubes, that you have to put values here, x square, x, y square. These are your A and B, A, B, because you have transformed your equation from x to A and B. So you better it's just rewrite this identity here, that A plus B multiplied by A square. Instead of x square you write A square, instead of xy you write AB, and instead of y square you write B square. So this will be very good for you, so that you can write xy equation into A and B form, because your first variable, which is x here, your x is basically 2x. This is your x, because 8x cube is a perfect cube of 2x. So it's better if you write in the form of A and B. So now that we have A cube, this is our A, so this is A cube plus B cube, which is equal to A plus B multiplied by A square minus AB plus B cube. So this is the factored form. So now just put the values of A and B. So A is 2x plus B is 5. A square is 2x square, which is 4x square, minus AB, minus A into B. A into B is 5 into 2, 10x, plus B square. B square is 25. So this is your factored form, or the factors of this polynomial 8x cube plus 125. So this is your answer. So this was example 1. Now example 2, y cube plus 64. So y cube is a cube of y, of course. 64 is a cube of 4. 4 into 4, 16, and 16 into 4, 64. So we write plus 4 cube. Now again you can write A equals y and B equals 4. And then use this identity in A and B form, because there is no x here. So you might get confused with this one. So use A and B. So A cube plus B cube equals A plus B. So your A is y. So y plus 4 multiplied by A square, y square, minus A into B. So 4 into y plus B square, y square, 4 square, plus B square, 4 square. 4 square is 16. So these are the factors of the polynomial. So this is a very simple illustration. These are very easy to solve polynomials. So now example 3. X cube is the cube of x and 216. This is the cube of 6. So 6 cube is 216. 6 into 6, 230, 6 into 6, 36, and 36 into 6 is 260. So now we have again a cube minus b cube. So a cube minus b cube, this is the difference of cubes, which is this one, and which is equal to, instead of x minus y, you put a minus b. Instead of x square, you put a square plus ab plus b square. So now your a is, this is your a, and this is your b. Just put the values in here, because a cube minus b cube equals a minus b, x minus 6, a square, which is x square, plus a into b, 6x, plus b square, 36. So this is the factored form. Product form, this is your answer. Last example, 48x cube minus 6y cube. So y cube is the cube of y, x cube is a cube of x, but 48 is not a cube of any integer. 6 is not a cube of any integer, because 2 cube is 8. So in this case, go back to the first principle. When we started learning factorization, what we discussed, that the first thing you will be looking for is the greatest common factor. This is the first thing you should be looking for any terms. If there is a number, a common number, common factor which you can take common from 2, 3, 4 terms, you first do that. So this is your first step always. Take common, and also look for the minimum exponent of any base if there is one. But because x and y, there is no base common, so the second principle is not of our use, the minimum exponent principle. In the first lecture, you can go back and see the lecture if you have not watched it. So first we take common. So 6 is common. So we take 6 common. Now what will be left inside? 8x cube minus y cube. Now it looks interesting, because 8x cube is the cube of 2x, and y cube is the cube of y. So now our a is 2x and our b is y, because this term is a cube of, I just change the marker, this term is a cube of 2x and this is a cube of y. So this is our a and b. So now because 6 is already there, so we have to take this 6 as a product of this whole thing. So we cannot remove this. So what we will do next is, we will take 6 like this, and then we can start a curly bracket just so that we don't do any mistake. So instead of 8x cube, we will write 2x whole cube minus y whole cube. Now this is the form of a cube minus b cube. So therefore we factor this up from this form to this form. So using the A and B notation, this one. So what we do is here is our A is 2x, so we keep this 6 like this. Our A is 2x, so we put in this formula A cube minus B cube equals A minus B. So 2x minus y, because our B is y. And then A square. A square means 2x square, which is 4x square. This is our A square. So we write 4x square plus AB, multiply A and B. So 2x multiplied by y is 2xy. And plus B square. So B is y, so y square. Now we have three terms being multiplied together. So this is our answer. This is a factorized form. So we just now open up, like now we use the same parenthesis because now we don't need this curly bracket. 6 is just a number, so we can write like this.